Hi guys, my name's Emma, and today I am going to model for you how we can multiply two-digit numbers using an area model and decomposition to make equations easier, simpler. So, I'm gonna cut this. Okay. Hi everyone, my name's Emma, and in this lesson, I am going to model for you how we can multiply two-digit numbers using decomposition to make equations easier or simpler. We will also be using area models, which we've visited before, to show our thinking. The reason we use models is because they help mathematicians to see the relationships between multiplication and the place value of numbers. We can create more simple equations and use addition to find the total using models, rather than multiplying large digit numbers by themselves. So, I just used a lot of big vocab words, so I want to start by going over some vocab and then we can jump right in. So, first and foremost, I stated that we are going to learn how to multiply two-digit numbers, two-digit numbers using an area model. And the area model is going to decompose our equation for us. So if you remember from our previous lessons, decomposing a number means that we are breaking it apart into its smaller parts. Now, you can do this however it is easiest for you to think of, but for these purposes, we're going to decompose numbers by place value. Place value, if we remember, we can take a peek over here. Place value is the parts of a number represented as larger numbers. So in the case of the number 36,420 or 3,006,420, the number 3 in the number, although it's shown as 3, we know doesn't actually represent 3. We don't only have 3, we have 3 million. So the number 3 can be represented by its single digit, but we know that it holds the place of 4 other zeros. And we can do that with each number in a or each digit in a number. And add zeros and add them together to get our total number. Now, a model, an area model we've used before, and an area model looks something like this. This is our area model. But this doesn't solve the math for us. We need to know how to use this drawing to model a certain operation. So, model, which I put our definition right here, is defined as a system used to represent or imitate something. Now, that doesn't really make a whole lot of sense by itself, but if we think about it, in the case of, let's say our equation is going to be 23 times 15. 1, 2, 3, 1. Ah, this is our equation. Our model, our picture, is our system. This is the system. This is like how we're going to input things, and this is our system. the system is representing the multiplication of our equation of our two-digit numbers, but it is imitating multiplication by showing it as decomposition and repeated addition. So basically what we're gonna do is we're gonna break down our number, we're gonna decompose our numbers into its partial products. It's another new word right over here. Our partial products, which is decomposing each number by place value to get its partial products, and we're going to input it into our model to imitate multiplication as repeated addition. Now, something all good mathematicians do is they label their work and they show all of their work. So we're going to show all of our work on the board. And I'm going to show you guys each step by step how we're going to do it. And then you guys are going to try it on your own at the end. So we have to label our model. So this is our model. We know that it is an area model, so that can be a label. And if this was a word problem, we could label it by what were the product, like what the label of the product is supposed to be. So if we were multiplying cookies by students, we could label it as like the total number of cookies per student. But for this, we don't have a word problem. So we can just label it as area model. And then underneath it, I'm going to put 23 times 1. And that's the best we can do right now with what we've got, which is good. So now we're going to break up our problem, our equation, into its independent variables. So variable 1 will be blue, 23. Variable 2 can be green. That's 15. And now we're going to find our partial products. So to find the partial products, to decompose our number, we learned how to do it like a tree. Like if you remember our little tree representation. So we're just gonna go like this, take our tree. And if we decompose 15 by place value, we know that if we go like this and just have the 1, that this 1 is in the tens place. So 1 times 10 is 10. Easy peasy. So we're going to have 10. And if we look at the 5 is in the ones place, just the 5. So we know that 5 times 1 is 5. So our other variable is 5. Now, if we think about what symbol goes here, we know that it's addition because this is our answer. And we know that 10 plus 5 is 15. So we can put an addition sign here. And we'll do the same thing for 23. If we look at just the 2, we know that 2 times 10, because it's in the tens place, is 20. We'll put our plus sign. And if we just look at the 3, and the 3 is in the ones place, and 3 times 1, we know is 3. Plus 3. Now, another way that you can look at these that might be a little easier for you to think about is we know that when you break down numbers, when you decompose numbers, you can get the same answer by thinking of it as an addition problem. So if we're trying to find 3 or 23 as a number, we'll do this in a different color. We're trying to find 23 as a number. We can decompose that in any way that makes sense as addition. So realistically, we could write 18 plus 5, because 18 plus 5 is 23, or 15 plus 8, which is also 23. But the easiest way for us to break this down is by its place value. Um, so starting here, we'll go with our blue first. Now we're going to input our partial products that we found into our area model. So this one's going to go here. And it'll be 20 and 3. And put our variables. And we'll do the same thing here. 10 and 5. And we can't forget to carry over our symbols. So we're going to put our plus. Now, the best way that I think to keep track of your work here is to start by putting in your multiplication signs. Because we know that every equation we're about to create in this area model is going to be multiplication. That's what an area model is. So next, I'm going to take my highlighter. Actually, we're going to do it in a different color because we're going to come up with new equations. So we'll do purple and pink. And I like to draw lines. So 20 will go here. And 3 is going to go here. Now 10 is going to go in these boxes. 5 is going to go in these boxes. So now we can see all of our cross sections. If this looks familiar to you, that is because as fourth graders, you learned in science about Punnett squares and how they create different genetic traits like blue eyes or connected earlobes or rolled tongues, like going like that. A Punnett square is an area model, so we're using the same thing. So if we apply what we know from science about Punnett squares and we connect our variables per box, we know that this is going to be 20 from here times 10. 20 right here. And this one will be 5. 3 will go here and here. This one will be 10. And this one will be. So now we have our broken down, our decomposed equation. So now we're going to move on. This is step 1. Actually, step 1 is going to be to decompose our numbers. This is step 1, right here. Decomposing our numbers is step 1. For a reason it can't look nice. Step 2 is inputting our numbers into our area model. So we'll go like that. Step 3 was to fill in our area model. So this one's going to be step 3. And now we're going to move on to step 4. So I'm going to come to the other side. And I'm going to label this right here. So, moving on to step 4. Step 4. Step 4, we're going to take each of these equations and we're going to multiply them. And then we're going to add them all together at the end. And that'll give us our answer. So we'll start with 20 times 10. 20 times 10. We'll set it up like this. Now, this looks ambitious. We're going to think about it in a different way. If we remember from our multiplication facts, when we multiply something by 10, we add a 0, right? We just add a 0. So this is the same. Just looking at 20, if we have 20 of something and we're going to multiply it by 10, all we have to do is add the 0. So this is just something that we already know. This is a multiplication fact that we already know. So we know that 20 times 10 is 200. Something that all good mathematicians do is they check their work. So I want to direct your guys' attention to, give me 1 second, my screen where my calculator is shared. So here we go. We can check our work by inputting it into the calculator. So if we do 20 times 10, we know that it equals 200. So we know that that answer is correct. So we know that our work right here is correct. Another way that we can check this though is just by adding 20 10 times. But that's going to take a really long time. And we don't need to do that because we're mathematicians and we know how to do math and we know that this is correct. So moving on, why don't we go to 20 times 5? 20 times. Doing 20 times 5, we can follow our multiplication algorithm. We can start here. 0 times 5 is 0, and we know that. So 0 here. Now, a little different than addition. There's no digit here, but we don't just multiply it by 0 because 0 doesn't hold this place. Also, 20 times 5 definitely doesn't equal 0. That doesn't make sense. So instead, what we do is we take this digit and we multiply it by this digit. 5 times 2 is 10. So if we fill in here, now if we want to check this, this is a little bit easier than doing 20 times 10 or 20 plus 20 10 times. It's a little bit easier. So we can check this one more on paper. And if I do my work over here, I'll just do our little note section here. And I did 20, 20, 20, 20. And I added these all together. 0 plus 0 plus 0 plus 0 is 0. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. And 8 plus 2 is 10. So we know that our work is correct. And actually, to show when we check our work, I'm just going to check mark, I think. So we know that this one's right. We know that this one's right. Now, 3 times 10. I'm going to do the same thing. Except for we know from our multiplication facts that we can just add a 0 here. So it's 3 times 10. And we know 3 times 10 is 30. But if we're going to use our regular standard algorithm, assuming that you didn't just know that already, because some people, not everyone does. We're going to do 3 times 0, which is 0, and 3 times 1, which is 3. I'm going to input like that. Capiche? And finally, we got 3 times 5. Now, there's no way to know this other than to just know it as a fact. Or you can add, like we did earlier over here. 5 plus 5 plus 5, or 3 plus 3 plus 3 plus 3 plus 3, but we're gonna do it like this. 5 plus 5 is 10. 10 plus 5 is 15. So we know that from our basic multiplication facts and from our checked work, this is 15. And same thing over here, if we check our work and we do 10, 10, 10, 0 plus 0 plus 0 is 0, 1 plus 1 plus 1 plus 1 is 3. So we know all that all of these are correct. Now we're ready for our last step. Finally, we're just gonna add all of our variables together. So 200, we can start here and we'll just do 200 plus 10. So 200 or plus 10, 100. If we add that, 0 plus 0 is 0. 0 plus 0 is 0. 2 plus 1 is 3. So now we have 300. 300. We already got this one. Underline it. We already did this one. Now we have to add 30. 30. 0 plus 0 is 0. 0 plus 3 is 3. 3 plus 0 is 3. And now we just have to add 15. Using our new 330 plus 1, 5. 0 plus 5 is 5. 3 plus 1 is 4. 3 plus 0 is 3 still. So our final answer is 345. But since we know that we are all great mathematicians, we're going to check our work. Because all good mathematicians check their work. Here. Here. Okay. So we're going to use our number. 345 equals, and then we're just going to put in our original equation, which is 23 times 50. 23 times 1. Now, we look at this, and we're going to check our work. A good way to check to make sure our answer is correct is to do the inverse operation that you just did. So the operation that we just did was multiplication. If you know the opposite of multiplication, great. If not, I'm going to explain it. It's division. Division and multiplication are related in the same way that addition and subtraction are related, in that they are opposites of each other. So if you want to cancel out an addition problem, you subtract. If you want to cancel out a multiplication problem, you divide. And those go both ways. So we have multiplication here, so we're going to divide. If you have, this is going to be our divisor, our answer. So 3, 4, 5 divided by, so we're dividing this by, and you can divide it by either one of these variables. Although I really like 15 because I see 2 5s here. So I know that they're both multiples of 5, which will probably make this problem really easy to solve, to check. So I'm going to do it by 15 because that seems like the smaller number, the easier number. 15, we're just going to divide like 1. 15 doesn't go into 3 because it's too small. But it does go into 34 because 15 plus 15 is 30. If you add another 15 to 30, though, it's definitely going to be higher than 34. So we know that this only goes into it 2 times. And 2 times 15, do this in another color. 2 times 15. 15 plus 15 is 30. Now, we have to have a placeholder here because we can't just subtract by nothing. So we're going to put a 0 here as a placeholder. 5 minus 0 is 5. 4 minus 0 is 4. And 3 minus 3 is 0. So we're all done here. Now, we know that 15 goes into 32 times. So 15 times 2 is 30. If 15 times 2 is 30, what's 15 times 3? We'll do a little side note. Because we just learned how to do this. 1, 5 times 3. 15 times 3. So 15 goes into 45 3 times. 3 times 15 is 45. And 45 minus 45 is 0, which means we have a remainder of 0. And we know that this is correct because I see all of our variables. I see our dividend or our answer, our sum right here. I see one of our variables here. I see the other one here. So, since this checks out, we know that this is good to go, which also means that we know that our answer of 345 is also good to go. Checking your work is something that every good doer of math does. And I hear you in your comments that we have calculators. And calculators, and even I used to get a lot when I was in school, that you don't need, like, you need to know these things because you don't just have a calculator carried around in your pocket. Like, not everyone just carries around a calculator in their pocket. Obviously now everyone has a phone and there's a calculator right on your phone. There's a calculator right on my computer that I just shared with you. Calculators are a great tool for checking work. And I love that we can use technology that way to quick check our work, especially like if you're buying groceries or out in just like the world and you don't have a pen and paper to write things down. But as learners of math, it is really important that you also check your work on paper. The calculator is a great tool. I love the use of that tool. It cannot be the only way you check your work because sometimes technology fails and it's not super reliable 100% of the time. You won't all, like, sometimes inevitably your calculator will eventually be wrong. And that is true of all technology. So we're gonna check, all mathematicians will at very least check their work one way on paper. If you want to check your work a second way using a calculator, great. Like, write that down on your work, let me know. Like, I want to hear that you're doing those things. But very baseline minimum, we need this. So let's try it for ourselves. I'm gonna give you guys a new problem, and you're gonna try and solve it all on your own. Your work, all of your work must be shown on paper for this new equation. You must, let's think. You must show all of your work. You must use our area model, like this. Your model must have labels. Again, if it's not a word problem, you don't need to do all that work. You don't need to make it a word problem. Don't reinvent the wheel with this. But labeled with the equation and what kind of model it is, since we don't have word problems. Your area model must be labeled, all your work must be shown, and you must check your work on paper one way. Now, I don't think I really stated this earlier, but when I checked this, another thing I could have done is instead of putting 15 here, I could have put 23 and divided 345 by 23. And my answer up here would have been 15. I checked that on a calculator earlier before we did this. But I also know, even though I did it on my calculator, I also know that my equation is correct because of this. So you must check your work one way. Remember, if you're doing multiplication, then you're going to divide your answer by one of your variables, and the result should be the other variable. So you divide the answer that you got, you put that in the brackets, like I did here, by one of these two variables, and you should get the other one as your answer up here. So I'm going to give you your new work, your new multiplication problem. 32 times 1. All right, this is your practice problem. Everyone try this by yourself, and I look forward to your responses. Now, after you work by yourself, I want you to use, this is my work. This is the work I did. I want you to check your work using my work. And if you have anything incorrect, I want you to highlight it and send me a picture of it. I want you to either tell me like how you would fix it or like what you did wrong, or like tell me that you don't know, because then I'll explain it, like that you don't know how you got that answer, or that you need some help fixing it. So take a picture of your work, email it to me, highlight anything that you got wrong that you might need help with, or any corrections that you make that would be look great. Um, anything just so I can make sure that you understand. Um, yeah. So we learned today that multiplying two-digit numbers is easier when we use models. We showed this by decomposing. Let me get our original work up here. Let's get our original work up here. We're going to start with our OG problem. We found out that models make two-digit multiplication easier by decomposing 15 and 23 into 10 plus 5 and 20 plus 3, and multiplying tens and ones individually and adding the 4 new sums that we came up with together to get our answer. Then we checked our work using inverse operations to make sure that our answer, which ended up being 345, was correct. We showed how we thought about it using our model, which is great. And I like this model mostly because each little square shows a part of the total answer. And I think that's really cool. I like how this shows it. Makes my brain happy. Um, in the future, we're going to use our understanding of this model to think of new equations and um new formulas and how it applies to multiplication and division.